All right, let's get started. We were working on linear algebra, working on equations. If I remember correctly. And the last thing I told you, I give you a list of things that you could do. And one of them was make sure you clear fractions and stuff first. So I thought maybe we should hit some problems that have that. That looks like, and I don't want to use yet. So let's do, let's start with something simple. 2x plus 5/3 equals 1. The hell?
Is there any way we can get, even if we change the number, some of the problems that are in the homework?
I need a little bit more information than that.
Yeah, like some of the problems, because there's some fractions that I couldn't figure out
Well, we
in chapter 7.
okay, we haven't gotten to the fractions yet.
Oh,
That's what we're doing today. That's why you couldn't do it. All right, so let's I don't like working with fractions. I could subtract the 5/3 over, like subtracting a number over, but I don't like doing that. I say fuck fractions. So what I'm going to do is multiply through by the common denominator. This one's got a pretty easy common denominator, it's 3. So I'm going to multiply both sides by 3. When I do, what? You're looking at me crazy, Bertha.
why is that the common denominator?
Because there's only one fraction.
Oh. Oh, that's fine.
We got to make sure we distribute both. So I got 3 times 2x plus 3 times 5/3 equals 1 times 3 is 3. On this fraction, this is like 3/1, the 3's cancel out. And I'm left with 3 times 2x, which is 6x, plus 5 equals 3. Since I did the same operation to both sides, I multiplied both sides by 3, the answer is still going to work, but now I don't have to work with fractions. I'm probably still going to have a fraction at the end, but I don't have to work with it the whole way. And so, yes, please sign me up for that. So at this point, now that there's no fractions, what would I do? Subtract the 5, right? If I subtract the 5 from both sides, I get 6x equals 3 minus 5 is -2. And the 5 and -5 go away. Ariana's not here yet. She'd like to see that crossed off, so I'll start crossing that off. Turn x is a whole number. I'm just gonna multiply or divide by its value on both sides. And if I do, I get that 6's cancel out. And I get x equals -2/6. But this simplifies. This is -2/2 times 3. And I can cross off 2's here, leaving a 1 behind. And so I'm left with x equals, I've got a -1 on top and 3 on bottom. I can check my work, and I'm going to just show you the walkthrough for it. I'm going to rewrite my original equation. And now I'm going to substitute in that value for x. Two times -1/3 plus 5/3. Does that equal 1? This is like 2/1. And so I can multiply these two fractions. I get 2 times 1 on top, which is 2. 1 times 3 on bottom, which is 3. I'm still adding 5/3. Is that equal 1? Now they both have a common denominator, so I can put them together. I've got -2 plus 5. That gives me 3/3. And so 3/3. I bring that down. I was checking to see if it equals 1, and it does. So that is the solution. Now, this one wasn't too bad. It was just one fraction, but it was the process doesn't change. So nice of you to join us. And sugar daddy has been a topic of every single class since Monday. I don't know. One other class that one of the ladies did have a sugar daddy. She said she didn't think it was a sugar daddy, but her mama called it a sugar daddy. And when we got the details, everybody was like, yep, that's a sugar daddy. Nope, you may say he's in the friend zone, but he doesn't know it.
Yeah.
Good times. All right, let's take a look at a more complicated fraction. One where the variable is on the bottom. The same strategy applies. Clear the fraction. But there's one other rule we have to make sure we pay attention to.
So did you end up looking?
What?
You end up looking?
For a sugar mama? No, I have not looked for a sugar mama yet. My other classes all have midterms next week, so I've been busy prepping for that. But I'm gonna look for me a sugar mama. The solution cannot make the denominator 0. Equal 0. So we got to pay attention to that when we're looking for it. In fact, we can and we should. You are a pain in my ass. You know that?
It's not my speaker.
Fucking pain in my ass. What does Borat say? A pain in my anus. What would make this denominator 0? What value of x? 0. So like right now, if I plug in 0, this bottom is 0. I'm gonna make a little note. I don't want x to equal 0. I'm gonna say x cannot equal 0. Let's make a little note of that now, and we can always check it later and make sure that's not the case. Most of the problems you work with in a trades thing aren't going to give a 0 unless you fuck up. But it's always worth, you can always check your work either way and then do it. So the same process applies. We're going to clear fractions. I'm going to multiply both sides. The denominator here is only x, so let's multiply both sides by x. This is the same thing as cross multiplying before someone asked me about cross multiplying. The x's on the left cancel out. And I'm just left with 7 on the left. And I have 21 times x on the right. Now, to finish it off, I divide by that number in front on both sides. And I get x equals 7/21. That simplifies though. 21 is 7 times 3. So I can cross those 7s off and replace them with 1s. And what I have left is 1/3 equals x. I'm gonna make a quick check. Nope, not 0. They're gonna give you in the homework, I'm not gonna give it to you on your test, but on the homework, they might mention an extraneous root. An extraneous root or solution is a solution that you get, but doesn't work. You calculate. But doesn't work in the problem. Like it makes the bottom 0. I can't really think of one in your like any trade skill where this is going to happen. And the fucking example they gave in the book is stupid. But I'm going to show you one similar to it. For example, if the problem is 0 over x equals 2. If I clear the fractions by multiplying both sides by 2, or by x, sorry, by x, I get 0 equals 2x. And if I divide by 2, I get x equals 0 over 2. 0 over 2 is 0. If I try to plug it in now, that was my original equation. I try to plug it in, I get a 0 on the bottom. And this cannot be. They call this, this is an extraneous solution. So there is no number that makes this a true statement. Which we could see if we just at the very beginning, 0 divided by x, that's just 0. 0 divided by anything is 0, and I would have had 0 equals 2. And there's that 0 doesn't equal 2, so there's nothing you can do about it. It never worked in the first place. It was a poorly written equation. That was the best they could come up with. I don't know of any other examples that I can think of where you, like trade skill stuff is based on real life applications, so you can't do shit that breaks reality. It's just not going to come up unless you do it wrong. Let's do a couple more fraction ones. I'll do a simple one, then we'll do a application in electronics. It's a good application in electronics. Let's kick it up a little notch. Let's do -1/4 x equals 9 minus 2/3 x. The easiest way again is to clear the fractions, but fractions. That should be how you approach this problem. But fractions, get them out. So what is the lowest common denominator here? Well, I've got two denominators. I've got 3 and 4. 3 doesn't change, and 4 is 2 times 2. That little table I gave you before should be how to do. We're going to see that it ends up being one of each. We got 3 times 2 times 2 is 12. I'm going to multiply both sides by 12. All right, so this is like 12 over 1. If I do that here, I've got 12 times 1 on top. I got a negative sign. 12 times 1 on top is 12, and on the bottom I've got 4. And I got an X. I'm just distributing right now. And then I will clean up any fractions that I have in a second. 12 times 9 is 108. And then I've got 12 over 1. I got 2 times 12 here on top, 3 on the bottom there, and I still got X. It trips me out how many fucking little camera things are on the backs of phones now. Like, what the hell do they need 5 different fucking holes for? You maybe one light, one camera, but what's the other fucking ones? There's just got 5 on the back. That's the light, and then there's 4 other little circles.
I know this one is camera.
Yeah, yours only has 2. Hers has fucking shitload. Hold yours up further. Show the people in the crowd. How many fucking little circles are on the back of that fucker? There's a lot. I don't know how they're for either. Maybe to like do the 3D rendering, like you can move it around and like get rid. I don't know. I don't give a shit. All right, so let's start cleaning this up. 12 divided by 4 is 3. So this becomes negative 3x. And I got my 108. Rather than doing like multiplying this and dividing, 12 is 3 times 4. If I replace the 12 with a 3 by 4, I can see that I can cross off the 3's now. And I'm left with 2 times 4, which is 8, and then an X. Now we're down to stuff we know how to work with. Let's get all of our variables on one side. Let's move if I move the negative 3x over here, it'll be plus 3x plus 3x. I'm going to have a negative 5x over here. I don't want a negative number. So what I'm going to do is I'm going to add the 8x to the other side. Got to do it to both sides. You got to maintain that balance. The left side is now 5x. I've got the equal sign. I got the 108. Since Ariana's here, I will cross off the 8x's. I'm not doing the vertical line through the arrow or through the equal signs. I can't do it. It drives me crazy. You can do it on your paper though. I'm gonna mark you down on the test if you do that. Not gonna route. Teasing. You can do the vertical. It's been a day. It's entertaining. All right, what do I do to finish this up? Yeah, let's divide by 5 on both sides. If I do that, I get x equals 108 over 5. I started with fractions, I should probably leave it as a fraction. I suppose I could turn it into a mixed number if I really wanted to, but. In terms of what you would do, let's make it a decimal. This should be 21.6. Is that right? Oh wait, I don't like doing that. I'm gonna make another line. X equals 21.6. Ready for another problem? Are we having fun? Yes, you are. Don't shake your head no. This is delightful. Let's look at a problem in electronics. Resistance. Resistance, total resistance in a parallel circuit. These are all in parallel. These are the symbols for resistors. Let's make one of them a 4 ohm resistor. One of them is a 10 ohm resistor. And one of them is a 20 ohm resistor. The way we calculate their total resistance are, the formula is 1 over R equals 1 over each of these values added together. 1 over 4 plus 1 over 10 plus 1 over 20. What this means is we can figure out the total resistance and replace that one circuit with just one resistor with this new value R. So if you do anything in electronics, that's what's going to happen. This is our equation now, and it's fractions. So what is my lowest common denominator? Let's take a look. I got 4, 10, 20, and R. We'll add in R at the end. If I do the little table, I've got 2 times 2. Here I've got 2 times 5. Here is 2 times 2 times 5. So the LCD is going to be 2 times 2 times 5, which is 20. It also has an R. I didn't put the R in there. We can add in the R, bring it down, make it 20R. So I'm going to multiply everything by 20R. And it might be easier to simplify them in a second. Just put them together. This is 20R over 1, and make sure you distribute it to each one. And 20R times 1, that's the numerator for all of them, is just 20R. So all we're really doing is writing 20R over the old denominators. All right, so. Let's just go through them. On the left side, I can cross off the R's and I'm left with 20. This one, 20 divided by 4 is 5. We still have the R. And we got our plus. 20 divided by 10 is 2. And we still have our R. And 20s cancel out, and we just have 1 R here. How many R's do I have total on the right? I read 8 R's, right? So if I divide by 8, we got R equals 20 over 8. That's 5 times 4 over 2 times 4. So I can reduce this to 5 over 2, which is 2.5 ohms. That's the symbol for ohms, which is a measure of resistance. It's nice. You can't smell back there. You don't need to cover your nose. I'll let you know. Sound a little wet, didn't it? Trying to gross you out now.
Oh, eyes are watering.
Your eyes are not watering. There's nothing happening. If it was happening, I'd already be fucking keeling over. You know, you'd see my face like the Jordan pain. All right, let's take a look at another type of problem that comes up that has variables in the denominator. Our work rate problems. So work equals rate times time. For example, just a simple one. If it takes 4 hours to paint a room, how many rooms can you paint? Or how long will it take to paint 12 rooms? In these problems, whenever you have a rate, the rate is always of some form where the time is on bottom and the job done is on top. So that's Ariana's make me zoom in problem. We'll see if she has glasses next week. We'll see if she's blowing smoke up our ass. So if I want to do the rate here, this is 1 room in 4 hours. So if I set this up, the amount of work done, the work I want done, I want 12 rooms painted. That's what I want to get done. So I can start assembling this little problem using this formula. My work is 12 rooms. My rate is 1 room over 4 hours. What? I just don't know how many hours, so I'll call it T.
You guys know.
You don't. You don't smell anything that came from me, because I don't.
You guys saw that, maybe?
Lies. Ariana's back there breaking wind at you. There's mass up here if you want some. Do you want to dare the Thunderdome? All right, you'll notice like if we wanted to, we can cancel out all the units here. Like I've got hours here, these cancel out. And I've got rooms on both sides, I can divide by rooms. I'm really, without looking at the units, but I set it up so that I can, the units I can see that everything's right. I've got 12 equals 1 over 4 T. 1 over 4 times T. So we multiply by, since it's a fraction, we're going to multiply by the reciprocal. I'm going to multiply by 4 over 1.
You know the website that's called Revamp Lesson?
Yes. I have a glorious score on it.
You have,
Fuck,
I'm kidding.
you're
I just
surprised.
did it. No, I just didn't see like,
This fucking hurts.
I just didn't see any comments that like, it was party and I'm like, man, what's this? Just woke me up.
It's a secret. Everyone knows to let the next group of students find out for themselves. It's like a surprise. It's a happy surprise. I'm pretty sure someone has mentioned somewhere in there the Chipotle protocol or something like that. I told you guys what the Chipotle protocol is, right? If you guys misbehave, you guys don't. You guys are good students, quiet, and other than making me fucking zoom in when I don't want to. The Chipotle protocol is for a class where there's disruptive students. And if they persist in being disruptive, I will threaten with the protocol. And if they continue just the next day before class, since I teach in the afternoon, my lunch will be Chipotle. And I will lock that fucking door. And just whatever comes out of me, comes out of me. But no airflow to make it go that way. But just permeate. Here, my 1/4 and my 4 over 1 cancel out. And I'm just left with T. On the left side, I've got 4 times 12 is 48. And T was measured in hours, so this is 48 hours. That's a very simple problem. We're going to do a more complicated one in a second.
This is
This is step 7 today. Next example. Bertha can paint a room in 2.5 hours. Fuck it, let's say 3 hours. And Ariana is constantly looking for a sugar daddy, and it takes her 4 hours. She stops to check. How long does it take them to paint their one room together?
Yeah, at least you spoke my name.
There's other spellings?
Yeah, it'll say like Mario on the page.
Those are two different names. That's fucking, this is grossly incompetent right there. I have a roster. How long does it take for them to paint the room together? Well, let's just reason out what's going on. You're painting one part of the room. And Ariana's painting the other, so it should be less. It should take you guys less time, right? And like your work kind of adds together. Whatever you do, she doesn't have to do, and vice versa. So we can add the work together. So like how much time, if I take that work equals rate times time. I can solve for time here by dividing by rate. And I get time equals work over rate. That's not somewhere I want to go yet. Let's just do this. Let's work with the work equals rate times time as it is right there, and we'll just do like the work. The work is the work job you're doing. So one room is the total job you're doing. You're painting one room. We have the rate. We're going to assume the time for both of you is the same because you're working together. You're going to stop at the same time. Bertha's rate is one room in 3 hours. And we don't know how long it's going to take, so we'll call that T. And Ariana's rate is one room over 4 hours. And again, we don't know how long it takes, but it's going to be the same amount of time as Bertha. So working together, we'll call that T as well. This is assuming if you don't just both say, we're going to paint, I'm going to do exactly half the room, and I'm not doing more. Like eventually, like this, Bertha's going to cover more than half the room in this rate. So you'll look over and realize at that point that you're working slower, but then you're going to be almost done. So let's just figure out how much time it is. If I ignore the words for now, I've got 1 equals 1/3 T plus 1/4 T. What's the common denominator here? It's 12 again, right? We just did a problem like this. LCD is 12. We'll multiply everything by 12. And I get 12 equals 12 over 3T plus 12 over 4T. We can simplify that. That's 4T plus 3T, which is 7T. And if I divide T by 7, or 12 by 7, both sides by 7, I will get T equals 12 over 7 hours. We definitely need a calculator for that one. T equals 1.71 hours. Almost 2 hours, but not quite. This next one, we're gonna set up the problem, but we're not gonna do it. I want to make sure you can see that you know what the setup looks like. But it's solving it this exact same way we've been doing here. And in the interest of making sure you guys learn more shit, we're gonna carry on. Let me allow you to finish writing this. So we've got a faucet filling a barrel. At the rate 1 barrel per 8 minutes. The barrel has a leak. Barrel leaks out water. At the rate of 1 barrel per 12 minutes. Which means it's filling up faster than it's draining out. Which means if we leave the faucet on, eventually the barrel is going to overfill. That's what we want to figure out. How long will it take for the barrel to overfill? Or overflow. Do I know about rating professors? That's when I'm feeling down, I go look at that shit and go, yeah, you're a fucking great teacher. How many jobs do you have where you have like this you're an awesome website to just make you feel better? It's a good gig. All right, so we got this barrel. And there's a faucet. And there's a hole. It's leaking.
There was one comment that you got once.
Yeah, someone said I said something that I didn't. I don't remember what they said I said, but it's mentioned in the post, one of the posts. They said I made someone cry and leave the classroom crying. I did not.
Oh wait, I think I saw that one.
I did not make, and no one left the classroom crying. I was so full of shit. All right, so water's going in, water's coming out. And so like I've got 1 barrel that I want to fill up. The barrel, the work being done to it to fill it up, we can do that rate times time. It's going to be 1 barrel over 8 minutes. And I don't know how much time. But then I got a leak, which is taking water away. It's taking water away, taking away is subtraction. We can subtract the other barrel, or subtract the leak rate, 1 barrel for 12 minutes. And that also has the same T. We're trying to figure out T is how long till it fills up. And T is in minutes. Because my rate has minutes in it. I guess we can solve it real quick. Common denominator for 8 and 12. If I got a 4 now, I'm gonna shortcut that. 4 times 2 and 4 times 3. It's 24. If I rewrite that problem without all those words in it, I got 1 equals 1/8 T plus 1/12 T. And I multiply that by 24. That's a minus sign in the middle and a plus. So I've got 24 equals. I gotta distribute this to each of the tops. 24 times 1 is 24. Got 24 over 8T minus 24 over 12T. When I simplify this, 24 divided by 8 is 3. So I've got 3T minus 24 divided by 12 is 2T. I combine them together, I get 24 equals T. T was in minutes, so T equals 24 minutes for the barrel to start overflowing.
What's your voting?
Aries. Why is it when someone asks you your sign, you say there's always that, like the knowing, yes, that explains everything about you. What was your takeaway from me saying I was an Aries?
Well, I'm not really into it, I just like.
Just curious.
It's like,
I don't know all the stuff for all the signs. I even forget Aries. I used to know. All right. Another type of problem that will yield decimals, as often has decimals, is the simple interest problem. I equals PRE. I stands for interest. P stands for principal. And this is the amount of money you start with. R is the rate. Interest rate, sorry, interest rate. So this is tends to be like a percentage over a certain amount of time. But when we use it in problems, we want it to be the decimal version. We don't want a percentage. And T stands for time. And we want these to be in the same units. These two right here, we want the same units. So David invests $1,000. At 4.75% interest. Per year. For 18 months. How much interest does he make? Now, the only real scenario where you have some shit like this is like a loan shark until you piss them off and then they start compounding it daily. Normally, when you do a loan or you do invest at a bank or something like that, you get interest compounded either daily or monthly or weekly. That's a much different equation. This is just like, what's the total interest after the whole time? So we want to plug in values for I equals PRT. The principal is $1,000. That's my P. This is my R, it's got a percentage. And T is how long he's investing. So that's 18 months. .75 as a decimal is 0.0475. And that's over 1 year. It's kind of helpful if you write down the units, at least when you first set up the problem. Because now when I look at it, if I go to put in 18 months, I can see that my years and my months don't cancel out. So I got two options. I could rewrite 1 year as 12 months, or I could figure out how many years 18 months is. What do you guys want to do?
How many years have you run?
You want to do? Hold on, Dave was talking first. Go for it, Dave. What do you want me to do? Put 12 down here? Okay. So we'll replace that with 12 months. That works. Now we've got the same units. So you'll notice months cancel out. And all I've got left is dollar signs. I've got 1,000 times 0.0475 times 18 divided by 12. And when I calculate it, I get 71.25. And the only units left is dollars, so it's $71.25. You guys ready for more? All right. Done with examples like that, I need to talk about inequalities and stuff like that. 7.4 has stuff on sets. So a set, inequalities and sets. I think maybe the easiest way to show you sets is give you an example. N is the natural numbers. Numbers that we count when we're adding stuff up. So we have 0, 1, 2, 3, 4, 5, and it can keep going. And what they do to indicate a set is they put brackets around it, curly braces around it. So they will say N is the set like this. I'm never going to test you on this, but I want you to, like when the homework shows you, you'll at least know what they're talking about. Whole numbers is W. And that's just like the natural numbers, but it starts with 1. There is no 0 in it. Z is the integers. That's like the natural numbers, but you have negative numbers. Q is rational numbers. I don't think there shouldn't be a number on these. Well, rational number might be. Rational has all the fractions. Which includes all the integers. Because I can make those as fractions by dividing by 1. So these are the rational numbers. The irrational numbers go by I. This is any decimal that doesn't end and doesn't repeat. Two of the most common ones, pi and e. But things like square root of 2, square root of 3, they show up in here. There's a lot in the irrationals. All of these make up the real numbers. So real numbers are like Q and I put together. integers go into Q, whole numbers go into Q, n goes into Q. So I can just list it like that. We call them real numbers because two other groups we have are the imaginary numbers. They use M for imaginary. These all have square root of -1 multiplied by. Square root of -1 goes by the letter I for imaginary. And finally, the complex numbers. These are all combination of a real number plus an imaginary number. It is highly unlikely you will do any of that. You deal with most of these things. Imaginary numbers, it sounds like it's like they're made up. But they are the basis for alternating current, the mathematics and science behind alternating current, which is the current we have in the wall. Our electricity is based off of it, so it serves a purpose. And if you happen to go down electricity far enough and study it, you'll learn more about it. But most people, that's unnecessary. I'm just showing you these just so you've seen them. I'm not testing you on this ever. Other things in this that I'm not going to test you on is set builder notation. Any problem that says set builder notation, skip it. Skip it. No one in any trade whatsoever is going to ever use this notation. I hate this notation. It's a math notation and I hate it. It's pointless. Not pointless, but there's better and clearer ways to write it. There is something called interval notation. You do need to know that. And it's based on inequalities. So let's talk about inequalities. These are your less than or your greater than. We've done this stuff before, right? Less than or equal to, greater than or equal to. If I have example 1, let's call A, let's use A. I'm going to have numbers in my thing. If I have 1 is less than X, which is less than 8. I'm going to draw this on the number line because it kind of makes it easier to see the interval notation. Over here is 0, here is 1, here is 8. I'm not putting all the dashes in between. For less than and greater than, we use hollow points on the number line. And we use parentheses in interval notation. Let's see in a second. So I'm going to put a circle on 1 and I'm going to put a circle on 8. And now X is any value between them, so I can shade the line between. If you don't like shading, it's a pain in the ass if you don't have a bunch of colors. Another way to do it is like do a little arrow, like a little line above them, connecting them. So that's another way of doing that kind of stuff. All the way to the left side of this is the arrow over here goes to negative infinity. And all the way over to the right is positive infinity. That becomes important in the interval notation. As you go from left to right, when you start hitting the numbers that are in your range, is when you start counting. I start hitting numbers at a 1, and I keep going, and I stop hitting numbers at an 8. So the first number I hit going left to right is 1. The last number I hit going left to right is 8. I'm going to separate those by a comma. And if these have hollow circles here, we are going to use parentheses. This is called interval notation. And I absolutely detest it. Because if you remember any like algebra at all, this is the way you would write a coordinate. And it is not a coordinate, it's a range of numbers. I personally, my favorite way of writing it is that. But you do need to know what it looks like on a number line and what interval notation looks like. Sometimes they do that. Let's do another interval where I have -3 is less than or equal to x is less than or equal to 2. I can do my number line again. Infinity, negative infinity. Got -3 here. I got 2 on the right. I got 0 in the middle. If you have an equal portion to it, like less than or equal to, or greater than or equal to, these are going to be solid points. And intervals will use square brackets. So since they both have the equal portion, I'm going to put a solid dot on them. That's what distinguishes them from this up here. These are hollow, these are solid. X is any number between them. So if I don't want to shade, I just want to do like that. That's a perfectly valid way. As we go from left to right, I first start hitting it at -3. I stop hitting it at 2. So I'll put a comma in 2. And now since I included the points, because I have the less than or equal to, I'm going to use square brackets. This one has a square bracket and that one has a square bracket. It can be one of each. You'll notice that these numbers are in the same order you see here. So sometimes you can skip the number line. If I had 4 is less than x, which is less than or equal to 9. skipping the number line, I'm gonna have 4 going to 9. And now this one doesn't have an equal sign, so it's a percentage or a parentheses. This one does have an equal sign, so it's a bracket. So you can mix and match. It's important to know. It all just depends on what this symbol is. You guys ready for some more? Yeah, you're sure ready. All right. Sometimes we don't have between stuff. Like if I just have like X is greater than 3. I can do my number line. X is greater than 3. This isn't open, it's a hollow because it doesn't have the equal part. I'm going to put a hollow circle there. Numbers that are greater than 3, if you've got 0 on there, it's pretty easy to tell whether or not which direction you go. 0 is not greater than 3, so I do not want to point in that direction. I want to point away from 0. So I can either make an arrow that goes like that to the right. Alternatively, if you like doing the shading, you can do the shading. When I do the interval notation, I start from left to right, I go along. I haven't hit it yet, I hit it at 3. And I never stop hitting it. It goes all the way up to infinity. So we will put infinity as that. It's an unending number. This is bigger than you could possibly imagine, then make it bigger. The infinities always get parentheses. So I'm going to do that there. And this thing defines whether or not this is a bracket or a parentheses. Since it's hollow, it's a parentheses. Let's do one that has a less than. So X is less than or equal to 4, let's say. So I have a less than or equal sign on the 4, so I'm going to put a solid dot on the 4. And then just check, is 0 less than or equal to 4? Yes. So I'm gonna point my arrow towards the 0. Now, when I do the interval notation, I start hitting my red line right away. I start hitting it at negative infinity. And as I move along left to right, I stop hitting it at 4. Infinity always gets a parenthesis. The 4 gets a bracket, yeah, because it's got the equal portion. The ones we were doing before, like just a quick blurb on it. When we had like 1 is less than x is less than 8. This is the same thing as saying 1 is less than x and x is less than 8. When you have them between, when it makes a sandwich has got an and in it, you can replace it with an and. Most people don't write it like that, though. If you put it together, this is the most common way, but even though the 1 less than x, most people don't write it that way. If I change the order of these, if I put the x on the left and the 1 on the right, the alligator, I'm gonna turn this into an alligator mouth. The alligator's got to be going after the same thing was going before. So here it was going after the x, now it's going to go after the x. So another way of writing that is x is greater than 1 and x is less than 8. So this is kind of really worth noting. If you swap sides of an inequality without doing any math, I didn't do any math, I just changed sides. Flip the inequality. Simple. There's one other type of inequality and interval notation we have is when we have 2 different regions that work. So let's say this comes along when we have an or. If I say like x is less than -2 or x is greater than 3. I make my number line. Put a greater than or equal to sign in there. It's like one of these I haven't. We can do them separately. The x is less than -2, I'll do it in red. I put a circle on the -2. And values that are less than -2 are to the left. X is greater than or equal to 3, I'll do it in green. put a solid point on the 3. And now I'm looking for numbers that are bigger than 3. Numbers bigger than 3 are to the right. When you do the interval notation here, we go left to right, we immediately hit it at negative infinity, which gets a parentheses. We stop hitting at -2. Again, we're going left to right. I get a parentheses. I keep going and then I hit it again at the 3, so it starts back up. The 3 gets a bracket. And it keeps going to infinity. And infinity gets a parentheses. When there's 2 regions like that, they put a big fat U in there. This means the union of the 2 regions, or union of 2 sets. Ready for more? Regions, sets or regions. All right, so 7.5 and 7.6 are on solving linear equalities. On solving linear inequalities. So these are just like doing the linear equations, everything we've been doing so far, but with an inequality symbol. And since we have the inequality symbol, let's talk about the 2 things that can flip the inequality. We already talked about one of them. The first one is if the values swap sides with no math. The second one is if you multiply or divide by a negative number. All right, let's take a look at a couple examples. 4x plus 6 is greater than 2x minus 2. If you can collect the variables on the left, with a positive coefficient, do that. It's much easier to read. This first problem is set up to do that. So I will subtract 2. What I'm going to effectively do, this is just like working with 4x plus 6 equals 2x minus 2. I'm only doing it this way once. I don't recommend putting an equal sign in. Because if you have to swap the direction or divide by a negative or multiply by a negative, you're not going to remember later on to change the sign. But for the purposes of showing what's going on, for the first one, I'm going to do it and then I'll put it back in later. We solved this the exact same way we did the stuff on Monday. I'm going to subtract 2x to get everything on the left. And if I do that, 4x minus 2x is 2x. And my 2x's over here go away. And while I'm moving the letters, I'm going to move the numbers over to the other side. I'll subtract 6 from both sides. That'll do away with plus 6 and negative 6 cancel out. And negative 2 minus 6 is negative 8. I can divide by 2. And I get x on the left, negative 4 on the right. And I didn't do any rules that caused a change in the sign. There was no swapping. I did move the x's over, but I did math to do it. So I didn't swap anything. So I'm going to keep the same sign I had before. If I do this on the number line, it's negative 4 is my target. I circle it because it doesn't have an equal portion. And I want numbers that are larger than it, which is to the right. I write this in interval notation. It goes from negative 4 to infinity. And we have parentheses on both. You guys ready for the next one? Next one. 3x plus 5 is less than 7x plus 1. I'm going to do this 2 different ways. How you choose to do it is up to you. But I want to show you both so you can make an educated choice. Option 1 move the x's to the left. We like moving x's to the left. I'm gonna leave the inequality in there. I'm gonna leave that inequality, and I'm just gonna subtract 7x from both sides. And to do that, I'm gonna also move the 5 at the same time. Here, the 7x's go away, and the 5's go away. And I have 3x minus 7x is negative 4x. And on the right side, I have 1 minus 5 is negative 4. If I want to get x by itself, I have to divide by negative 4. You have to do the negative sign. You cannot leave it. That's usually where people make mistakes, is they just ignore the negative sign and pretend it just disappears. On the left side, the negative 4's cancel. They're really left with 1s. And I get x over there. Negative 4 divided by negative 4 is positive 1. I divided by a negative number. I have to swap the symbol. Or flip the symbol. Divided by a negative. Let's say you didn't want a negative number in front. Let's say you go, I don't want to have a negative 4x. Instead, I'm going to move my 3x by subtracting 3x from both sides. And that means I'm going to move my constant numbers to the left by subtracting that one. On the left side, the 3x minus 3x goes away. On the right side, the 1 minus 1 goes away. I've got 5 minus 1 is 4. 7x minus 3x is 4x. If I keep going, I'll divide both sides by 4. And I get 1 is less than x. That's harder for me in my head to graph that way. So if I want to swap sides, if I put the x on the left and the 1 on the right, without doing any math, I gotta make sure the alligator keeps changing the same thing. So I swap sides here with no math. You'll notice in both cases, I get x is greater than 1. So you're free when you have a problem like this to choose whichever approach you like. I personally like the thing on the right because even the great, powerful Oz, the Wizard of Oz that I am, I will fuck up negative signs more than anything else in mathematics. It's really easy to forget that they're there, not write them down. All it takes is the fucking dog barks or something like that, and you don't put the sign, and it just magically disappears and it's wrong. Here, I avoid that negative sign problem. The only thing you have to remember to do at the end is to change the order, and that's easy to remember. I treat it as an alligator, or you can treat it as like Pac-Man, if you like Pac-Man. Pac-Man keeps going after the same meal. It's easy to remember the swapping sides. Yeah, video game reference. If we do this on the number line. We put a hollow circle on the one because there's no equal portion. And we're looking for values that are greater than. A little bit more, we're gonna be here till 6. Oh. And if we do the interval notation, we've got 1 to infinity and they both get parentheses. Okay, so the 7.6 is when they're a little more complicated, like when they're called compound inequalities. That's where I had, this was the first example we did with a compound inequality. We had 1 less than x less than 8. That's an example. So let's just do a problem at half. Example. 17 is less than or equal to 5x plus 7, which is less than 32. The rule we had before, what we do to one side, we do to the other side, still applies. But now it's to every side, every section. So if I want to subtract 7 from the middle to get rid of it, I have to subtract 7 from both other sides. (17 minus 7 is 10. 32 minus 7 is 25. And now, if I want to finish it off, I need to divide the middle one by 5, which means I need to divide everything by 5. I'm left with x in the middle. (10 divided by 5 is 2. And 25 divided by 5 is 5. If I do this on a number line, the 2 gets a solid circle. The 5 gets a hollow circle. And I'm looking for values between them. In the interval notation, we start at the 2, we end at the 5. The 2 gets a bracket, the 5 gets a parentheses. Not too bad. This leads to, there is one important rule to note. Never, ever, ever mix the directions of the symbols. So do not have A is less than X, which is greater than B. Don't do that. That's a no. Bad dog. And do not do this. They're pointing in different directions. Also, no, don't do that. They always point in the same direction. Here, right here, both mouths are opening to the right. This was an example of the and compound inequality. Let's take a look at the or. Are you done? Yeah, are you sure? We could have a scenario we have x plus 3 is less than -2, or x plus 3 is greater than 2. The or, there's no way of combining them. This is where students get into start making mistakes with the doing this mixed symbol shit. The or is where students start trying to do that. Don't do it. Just solve for each one individually. Here, if I subtract 3 from both sides, I get x is less than -5, or I'll subtract 3 on this side. I get x is greater than -1. We draw this on a number line. I'm looking for values that are less than -5, which would put a circle at -5 going to the left. X is greater than -1, puts a circle on -1 and shows values going to the right at -1. If I do interval notation here, I just start writing down the symbols where my line hits it. And these get parentheses, these get parentheses. Since there's 2 of them, I put a U. I'm not sure why the book has this, and the homework might have it, a scenario where there's no solution coming up. Maybe it's if you're trying to do something you just can't do, and you set up the equation anyways. Like you don't know that you can't do it, so you try. So if I had 6 is less than or equal to 4x plus 9 is less than 3. You can go through and solve this. But if I cover up that thing in the middle, this says 6 is less than 3. Is 6 less than 3? No. This says 6 is less than 3. This is not true ever. So if you recognize it right there, you can stop. If you don't, you can go through and solve it normally. Subtract -9 from every side. Divide by 4 everywhere. And I get negative 0.75, 3/4 is 0.75. Is less than X, which is less than negative 1.5. Which is 6 divided by 4. When you put these on a number line, the negative 1.5 has to be lower than the 75, which means it goes on the left. If we look at this though, this is saying X effectively is greater than negative 0.75. If I change the order, so that's saying this direction. If I look at that part, that says X is less than negative 1.5. That would be this direction. But it's a sandwich. It's a sandwich. It needs to be in the middle. It should be here. This is really hard to recognize that that's not right. It's really easy to go, that's the right answer, and just run with it. Or it's easy to put these in the wrong order, and then the sandwich thing works. But the very principle that these two numbers, one is less than the other, isn't true. It's easier to check for that shit in the beginning. Check to see if the outside, like the operations, the outside things make a true statement. Generally, in real life, if you set the problem up correctly, that is never ever going to happen unless you're just trying to do something you can't do. Fit a square peg into a round hole. It ain't gonna work. That's it for chapter 7. I will see you guys on Monday.